Hello, my name is Agnes Nadama Ogo. Today I will be discussing neuroplasticity, which refers to the brain's remarkable capacity to challenge its structure and foundation in response to experience. This concept is foundational to modern neuroscience and has profound implications for learning, development, and professional practice. Neuroplasticity challenges the outdated belief that the brain becomes fixed after childhood. Instead, research shows that the brain continuously reorganizes itself. This includes straightening or weakening synapses, forming new connections, and even generating new neurons in certain regions. These changes occur as a direct result of learning, experience, and environmental output. There are two primary mechanisms of neuroplasticity. Structural plasticity involves physical changes in the brain such as dendritic branching or synapse formation. Functional plasticity refers to the brain's ability to shift functions from one region to another, which is especially important after injury. Both mechanisms are driven by activity-dependent processes like long-term potentiation, which straightens synapses through repeated activation. Research constantly demonstrates that neuroplasticity is experience-dependent. Golub and Gibbs' work shows that repeated practice straightens neural pathways, while Zatorek and colleagues have documented structural changes in both gray and white matter during skill acquisition. These findings illustrate that learning is not just a psychological process, it is a biological one. Current research trends highlight the relevance of neuroplasticity across multiple domains. Trauma-informed neuroscience examines how chronic stress alters neurodevelopment. Digital neuroplasticity explores how technology uses and reshapes attention and memory. Aging research focuses on preserving cognitive function, while neuroplasticity-based therapies aim to rehabilitate lost skills through targeted practice. Neuroplasticity also shapes how individuals interact with the world. Experience, relationships, and environments continuously influence neural wiring. Positive, enriched environments promote cognitive growth, while chronic stress or trauma can disrupt neural development, particularly in regions responsible for emotional regulation and executive functioning. Cognitively, neuroplasticity underlines memory formation, attention, problem solving, and emotional regulation. Every new skill or concept learned results in measurable changes in neural pathways. This explains why consistent practice and repetition are essential for long-term learning. In my field of interest, neuroplasticity provides a scientific foundation for many evidence-based practices. It validates the use of individualized instruction, targeted intervention, and scaffolding. It reinforces the importance of early intervention, as the developing brain is especially responsive to environmental input. I chose this topic because I am deeply interested in how learning physically transforms the brain. Understanding neuroplasticity helps me better support individuals in my future career and challenges the misconception that intelligence or ability is fixed. Some of the most important things I learned include the brain's lifelong capacity for change, the biological basis of learning, and the powerful influence of environment on cognitive development. These insights help explain why individuals can continue improving throughout their lives. These insights are significant because they encourage a growth mindset grounded in neuroscience. They also help professionals design the interventions that align with how the brain actually learns. Understanding neuroplasticity highlights the importance of reducing stress, providing support, and creating enriched environments. It is important for others to understand